All right, so our project is on the James Webb Space Telescope and its effects on exoplanet. So first, the James Webb Space Telescope is NASA's most recent and most powerful telescope that has been launched into orbit around our sun. It has giant 6.5 diameter gold mirrors, which allow it to collect more light than any telescope before it. And this allows astronomers to observe fainter and more distant objects. And so one of its primary goals is to study exoplanets. By analyzing exoplanets, the JWST can identify signs of habitability or even life. And the instrumentation on board the JWST is primarily focused on the infrared spectrum of light. And so this allows scientists to see through cosmic dust and gas that has blocked visible light from reaching prior telescopes.
So one way that space telescopes can detect exoplanets is via transit detections. When an exoplanet moves through its orbit, it will block a portion of its star's light. By measuring the amount of light that a planet blocks as it moves across its star, the JWST can determine the size of a planet. Additionally, the infrared spectrograph analyzes the composition of an exoplanet atmosphere by analyzing the infrared light that passes through the planet's atmosphere during the planet's transit. Specific wavelengths of light will be absorbed, and this can tell scientists if the atmosphere of said planet contains compounds like water, carbon dioxide, or methane, all of which are important elements of a habitable planet.
Direct imaging is a method used by the James Webb Space Telescope to capture actual images of exoplanets by separating the light of the planet from the overwhelming glare of its host star. This technique with the coronagraph allows JWST to study planets and other celestial objects that would otherwise be obscured by their nearby stars. Because JWST operates in the infrared spectrum, imaging exoplanets is much easier to do. Many exoplanets produce more radiation in the infrared spectrum than in the visible light spectrum, which allows JWST to find dimmer and smaller planets.
These are pictures from James Webb of an exoplanet called HIP 65426b, a gas giant about 10 times larger than Jupiter and 385 light years away from the Earth. This 20 million-year-old planet's orbit around its star is about 100 times larger than Earth's orbit around the Sun, and this makes it an ideal candidate for direct imaging because it is easier to block out the host star's light, as seen in the coronagraphs above. The white star indicates where the star would be.
From the data obtained by the James Webb Space Telescope, astronomers can determine the size, mass, orbit, and atmospheric composition of an exoplanet. This is extremely important information when it comes to determining if a planet could have liquid water and be habitable. JWST can detect gases like oxygen, methane, carbon dioxide, and water vapor, which are potential biomarkers for life. The presence of these molecules in the atmosphere could indicate that a planet has the necessary conditions to support not only human life, but possibly alien life.
All right, and these are our sources. Okay, that was good.